pipette bulb, and we're gonna draw up some blue water with the pipette and put it into our smaller beaker. And first we're gonna start by dropping it down into the water and make sure that the tip of the pipette does not hit the bottom of the beaker. And then we're gonna have the other hand squeezing the bulb before we put it on top. And we're gonna put it on here tightly. And then we're gonna slowly release, drawing up the blue water. And then we're going to take it off really quick and use our other thumb to stop the flow. And we're going to let this down to 0 so we can take a more accurate reading. Alright. Now, this is where, we're about to take our initial volume to begin with. And so the initial is right at 0 if you look at the bottom of the meniscus.
A meniscus is a curved surface at the bottom of the column of a liquid. In class, this liquid is usually water and some sort of aqueous solution. And as you may have noticed, the water is in such thin glass tube. It does not have a flat surface at the top. And so the top is curved inward, making it difficult to decide where to read the volume. So the meniscus is read from the bottom.
Okay, now we're going to continue, and we're going to release 5 milliliters of the blue water into our smaller beaker. And to do this is 0, so we're going to go down to 5. That'll equal 5 milliliters. So we do this by slowly releasing our thumb, so it'll go down, letting out. And then when we get closer, we need to slow down some. We need to get to eye level. And then we're going to go to the bottom of the meniscus. The bottom of the meniscus reads about 5.15. So there's 5.15 milliliters in the smaller beaker. And that's going to be the volume that we weigh using the balance.
Now we're going to measure out 3 milliliters of water with the pipette. Now we want to make sure that we prime the pipette between each use. So before I did this, I rinsed it with water 3 times. Now I want to take our bulb and squeeze it and put the pipette in the water, not all the way to the bottom, and I want to make sure that I have my thumb ready to stop it when I get it up to the top. Now we're going to start by going up to 0 to make it easier to measure the 3 milliliters. I'm going to get it down to 0. There we go. So that's going to be our initial volume, is 0.
Which I'm recording down in the notebook. No, my bad. No, yeah.
Okay, now I'm going to put 3 milliliters of water into this beaker so that we'll be able to weigh it later. So I lift up my thumb a little bit. Careful to go slow to get it down to the 3. And we want to get down on eye level so that we can see where it's going to be at. Now that's right at 3 milliliters, and so that means that's our final volume, which means that there are 3 milliliters in this beaker. I'm going to pipette 1 milliliter of water. So first, I get the pipette and I lay it midway into the solution. Not all the way to the bottom, because then you get air bubbles and those are bad. And I get the bulb and I squeeze the bulb all the way in so that I can get all the water up in the pipette. So I put the closed pipette bulb on top and I increase and I close it up. Now I'm only taking 1 milliliter of water, and this is perfectly on 3. So now I'm going to slowly release until it gets to 4. And I always wonder, why does a meniscus never lie flat?
Well, it has to do with the nature of the water molecules and the glass molecules themselves. Water is made up of polar molecules which have positively and negatively charged ends. Since opposites attract, the positive sides attract the negative sides, and all of the molecules stick to one another. This is why water droplets can form. Glass molecules also happen to be polar. Again, since polar molecules like to stick together, the water in a glass tube will actually tend to stick to the sides of the tube. You can see this at the top of the graduated cylinder, where the water will slightly creep up the sides and form a curve, which is the